Hello, hey everyone. Very good evening. Thanks for joining us on a Friday, rainy, stormy evening. I'm Fuzz. I've been a regular on this series for quite some time right now. So welcome to the Going Cloud Native series with AWS, and we've been doing the series since early July. We've covered a lot of topics already up front until recently. So just as a recap, I'm just going to be showing you a couple of things that we've been doing. So we started with cloud infrastructure. We spoke about the cloud. We spoke about why it's required, what problems it's solving, and what are the different building blocks from there. And then we started diving deeper into those blocks like networking and then storage and databases. And then from the last 2 weeks, we've started bringing on guests, and we had Ped from Photobook, who's the CTO for Photobook, who joined us and spoke about security on the cloud. Pretty interesting session because coming from his background and him having a more holistic view of how things work on the cloud gave you an idea of what the approach should be on security. And you would have noticed that there was a lot of stuff covered in that. And what we'll be doing is in future sessions, as and when we do app development as a series, in fact, that's some of the things we may be talking about later. We will dive deeper into what are the different aspects of security you can do from a cloud perspective on the accounts itself, infrastructure-wise, and then also on your application, like data security and even your application security in general. We skipped the app development for now. That's something we are thinking of actually spinning off into its own series, which is what we'll be pointing towards in the end. And we'll be going on to our next topic, which is DevOps. So just a bit of a highlight for other things. If you are looking at other videos and more intense and more hands-on kind of series of videos, we have our own channel. So this whole series is also backed by AWS DevX, which is Developer Accelerator. It's an initiative from AWS which brings to the fore the best of what you can do on AWS by our solution architects. We have people coming in and sharing about how you can build different kinds of projects on AWS. So we have a Twitch channel where we have a lot of content being generated every week. We also have localized content coming in. Right now we have it in Thai, and we have it in Bahasa, Indonesia, and even in Vietnamese. And there's more stuff coming on board. We're bringing in a lot of folks from within AWS globally to come in and share about their experiences. So a very good place to actually go if you already have a handle of the cloud and you want to see what's the full potential you can push it to. So this is basically the link. So you can check it out over here, and I'll be pasting this link later, and you can also view this YouTube video later to just have a look. And for today's session, if you have any questions, you can just go to slido.com and you can go to this code AWS Going Cloud Native GCN DevOps, and any questions or any comments, you can put it over there. But also use YouTube liberally. You can put any of your comments. We can actually show it across over here, so we can make this more interactive. Also, your feedback matters. Every session we do collect your feedback, and we try to tweak the topics and even the content as much as possible. We had noticed in the initial comments which were coming in that folks were asking for hands-on and more experienced kind of talks, which is why we started bringing in guests who would also share from their experience of how they've built stuff. In my case, I'm guessing, okay, you guys would have also got bored seeing me always. So yeah, definitely it adds a bit of flavor when we're bringing in people. So with that, I want to introduce today's guest. So today we have Thiru, who's a Partner Solutions Architect at AWS. Some of you may know him from a previous cloud provider, who shall not be named. But he's someone who is known in Malaysia for promoting the cloud in every form possible. And he's also a Kubernetes and a container extraordinaire, one of the best guys I've known who has brought containers and Kubernetes to the communities in a much more simpler manner. And if anytime you're looking at a very advanced workload, or you're looking at even why do we even need to use containers, he's the kind of person you should be approaching. So without further ado, hey Thiru. You're on mute.
So you talk about containers, but you forget to unmute. That's just how it is. So thank you very much, Faz, for that introduction. and obviously it's been really great to be able to do this. And as first mentioned, I was from another cloud provider. It could start with a G. I'm now with AWS. I've been with AWS for a little while now, and so today I'm going to talk to you about how do we do cloud native DevOps on AWS. So with
Cool.
that, let's just get started. Yeah.
Yep. The floor is yours now.
Thank you, first. Okay, so today we'll cover a few things. We'll cover what is DevOps all about and why Amazon does DevOps the way we do. We'll cover a little bit about the different DevOps style services that we have. Since they are predominantly developer specific, uh, AWS services tend to follow the form code something, which we will look at. And in addition to this, how those services tie into the whole DevOps portfolio within the AWS ecosystem, and then finally followed by a bit of a demo. Hopefully the demo works. If the demo gods bless me this evening. So why is DevOps important? So when an organization adopts a DevOps strategy, we usually find that there are a lot of improvements, especially when it comes to the quality of the software you deploy, as well as the way the teams work within the organization. And obviously, the entire culture of the organization becomes better as well, because when you have fewer people arguing with each other about whose job it is to do what, obviously everything works better. So we've and you know research with research we've gathered that with a DevOps strategy you can have almost 50% more time spent on new features as opposed to using that time for more menial activities like patching and such. Before we go deeper in, we need to talk a little bit about what DevOps actually is, right? So, as I mentioned earlier, DevOps isn't just a set of software and tools. It is actually a mindset. Uh, when organizations adopt DevOps, they almost always tend to adopt tools. Uh, Companies which have done DevOps well have covered all these three different things. But in my personal opinion, DevOps almost always needs to start from a change in culture, something that you need to do better within the organization before you actually start looking at tools and services. You need to start with the people first. But that's just my opinion on that. So once you adopt that kind of culture, obviously this is a technical talk, so we're not going to go into what you need to do to change your employees' mindset in an organization. But suffice to say that once you start walking down that path, the practices and the tools follow by themselves without you having to push those tools into your engineers. Okay, so from a culture perspective, obviously DevOps stands for the development and the operations side of things coming together. There are lots of new terms now. There's even DevSecOps, which includes security as well. The other day, someone during lunch, someone was talking about how you actually even bring HR into this. So it's HR DevSecOps. Don't even know what that means, but hey, more buzzwords, right? Um, Aside from development and operations coming together, there also needs to be a shared responsibility between teams. It's not it's not shifting blame if something goes wrong, or not being responsible when something needs to be done. It's sharing responsibility across the wider engineering team, and establishing more transparency in communications, as well as laying out exactly what the scope is, as opposed to saying everything belongs to the DevOps team. It still happens. Next, let's look a little bit about excuse me, the tenets or the principles behind DevOps, right? So more often than not, uh, when an organization starts to adopt a DevOps strategy, they tend to decompose their monolithic applications into more microservices or a services-based architecture. And if I'm being more particular, I think more and more organizations start off by being a service-oriented organization where they build services instead of a monolithic application. But that's not to say that you have to do everything in a microservices manner. You can still do a lot of things even in a DevOps style with a monolithic application. But again, I guess it just depends on how that organization behaves. Then comes the automation piece. So when we talk about automation, there are two major things, the integration and the delivery or the deployment phase. So we'll look into this in a little bit more detail later, but just for now, let me just say that you might have heard of CI/CD. So continuous integration and continuous delivery or deployment is the founding principles of, or rather it is CI/CD. Then we model all our resources using code. So for people who have adopted DevOps, you might be familiar with using Terraform, which is one of the more popular infrastructure as code platforms. A little bit closer to home, we have CloudFormation from the AWS side. We need to keep track of what our applications are doing. So traditionally, we've always had logs, but now we need to log at a more deeper level. We need to understand exactly what happens within our services. So we've got more emphasis on things like observability, tracing, and so on. So we discussed a little bit about what DevOps is. Now, talking about why and how DevOps can benefit you, we showed you a little bit of statistics earlier, and I also spoke about how things within the organization improve as well. But another often overlooked advantage is how reliable your software is. So once you start to adopt that kind of culture, you find that your applications tend to be more resilient to failures because you adopt a lot of foundational processes before you start going onto CI/CD. For example, you need to test a lot, so you spend a lot of effort on creating automation for testing, and that actually directly benefits reliability, amongst all these other things as well. So earlier I talked a little bit, or at least I said we would look at how DevOps has been done and is still being done at Amazon. So there's a little bit about that here. When we first started out, obviously we were also on a monolithic architecture just like everyone else. And then we moved on to a microservices slash service-oriented architecture. And I think, I can't be too sure, but I think Amazon may have come up with the two pizza team concept. So for those of you who don't know, two pizza team is a team size where two regular size pizzas are enough for lunch. This is obviously for those people who can't eat a lot, but if you really like your pizza, I guess this doesn't apply to you. But yeah, for the normal average person, two pizzas or at least a couple of slices in a regular size pizza is fine. So anyway, too much about pizza. I'm probably hungry. So to go towards this, we built a lot of tools to automate our development and release process, and a lot of it is what we use and created the software that we actually give to our customers as well. So one of um, earlier I talked a little bit about CI/CD, right? One of the things about a CI/CD platform is we usually call it a pipeline. And the reason why we call it a pipeline is because we actually send the code from one place to another through a pipe. And through the pipe, we have different stages. So these stages can be building the code, testing the code, deploying the code, and so on. And the reason why we have this pipeline, as opposed to having bash scripts for every process, we still can do that, but we have pipelines in place because it is repeatable, it is an established process, and we can have visibility across the entire process as well. When you use something like a bash script to do DevOps, you can still get your job done, but how do you exactly know what's going on, right? And from Amazon's perspective, this has been very successful because now we've got thousands of service teams all across Amazon, not just in AWS. I'm talking about the wider Amazon organization, so that includes retail, Alexa, and so on. And pretty much every single team uses these principles that have been developed over the past 10 or more than 10 years. We have something called tech survey within Amazon. Again, this is across the wider Amazon, not just in AWS. And one of the things that our developers have been very happy about is the build process. So essentially the pipeline service. Uh, all the developers need to do is just write really good code, and we've got all the mechanisms and the processes in place to get the code from the developers' IDEs all the way up to production. So how do we do DevOps? First, we write the code, we build the code into an artifact, we test it, we deploy it, and finally we monitor it. So this is the source. The first phase is source, which is writing the code. So we check in code using some sort of source repository. So the source repository is really important. We need a mechanism to build the code, whether it's compiling the code or packaging it into some sort of container or something like that. We obviously need to test it, as I was talking about earlier. Testing is a very integral part of this process. We need a repeatable, um, standardized way of deploying that artifact after it has been tested, so that we can ensure that nothing goes wrong in the deploy process. And even though we test it, there still can be things that go wrong, so we need to monitor the code in production to determine if everything's going well or if there are things that go wrong and so on. So the continuous integration process starts from committing the code to source and then building it. This is CI. Continuous delivery goes from source all the way to production. And continuous deployment is beyond that. From an AWS perspective, I think we have a little bit of problem with the animations, but from an AWS perspective, we have services that cover the entire spectrum of this process. So from source all the way to monitoring. And we've got all of these different services, which we will look at in more detail later. But for now, I'll just give a brief introduction. So code commit is a source repo. Sorry, I just have some questions. Code commit is our source repo. Code build is our build platform. We can do testing with code build and some third-party tools. Deployment is with code deploy, and finally we have CloudWatch, which everyone knows and loves, and we've got X-Ray as well, which is pretty cool. The entire process is finally orchestrated by something called code pipeline, which we will actually look at in our demo later. Finally, to bring all of these together, we've got CodeStar. I'm not actually going to go into too much detail about CodeStar, but CodeStar is the orchestrator that handles this entire process. So imagine a pipeline for a pipeline, if you will. At a glance, again, just to rehash, we've got on the far left the development and delivery toolchain. In the middle, we've got our infrastructure as code, which obviously CloudFormation is an integral part of. And monitoring and logging is not just for DevOps, it's for things beyond that, even for standard virtual machines, other applications that we have, other applications and services that we have, and obviously for repeatability as well. AWS config is also not something that we will look at, but it's part of this entire portfolio. So let's start with the first process, which is building and testing your application. And our first service is code build. So code build is our managed automated build service. And what it does is it imagine Jenkins, if you are familiar with Jenkins, but a managed version of Jenkins that AWS actually built and offers customers. And what code build does is it takes your code. Once you are committed to source, it either compiles it or just packages it into a container, or maybe another artifact as well. And the way code build does it is it actually uses layers of Docker images for each part of the build process. So there's usually like a pre-build, a build, and then a post-build process as well. But yes, without going into too much detail, because we've got a lot of things to cover and not much time. So how does it work? It downloads the code, it runs the build commands, it outputs logs to CloudWatch, and finally it stores the artifact in S3. To orchestrate cloud build, we can use code pipeline. We can also use other orchestration tools, Jenkins or something like that. We can use AWS built-in build environments, or you can bring your own builders. And obviously, as with everything else in the AWS ecosystem, everything is API or command line driven. Let's taking a look at questions. Okay. On a side, I also wanted to talk to you a little bit about what building code actually means. So we've got two sorts of languages, or two broad categories of programming languages, interpreted and compiled. So compiled languages tend to be more systems-oriented languages like Golang, C, C++, Java, C# and the like. And the compile process is usually what happens with when we say building, right? But building also can mean creating an artifact, because you also still build that artifact from source. But there are languages that don't need compiling, and these are interpreted languages like Node.js, Python, and so on. There are obviously the reasons why we use different languages. I don't need to go into that, but when we want to run the code, we still need to package them. So that's essentially what code build is doing. Code build can also test your code, but it doesn't do that in a separate service. So how code build does it is, because we use Docker containers in each layer of the process, we use a testing layer in code build as well. And, uh, and this is actually really useful because we can combine both the build process and the test process in the same service. Where do you focus your tests? We tend to split testing into unit testing, service testing, and UI testing. And the least is usually the UI testing, and the most is the unit testing. And for unit testing, it's a lot easier because you can automate that process, which is what code build does. And for UI and service testing, we unfortunately have to include or use third-party utilities. Let's go check the questions again. Okay. Now we talked about building. Let's talk about deploying those applications. Code deploy is that service that actually pushes that artifact into our instance that is actually going to run that artifact. And if it were not for code deploy, we would have to copy the package into our instance, whether it's ECS or EKS. We have to manually change the running container into our new container and do a lot of manual tasks. Obviously, we can script them, but code deploy handles all of this out of the box. With code deploy, we can change the deployment style. We can change the deployment group as well. So we can either do a one at a time strategy, which is sort of like a rolling update in that sense. We can do a half at a time strategy, or we can just go big bang approach and deploy it all at once. We can also deploy to a specific group of servers, either dev or prod as well. So we talked about the builder and we also talked about the deployer. Now we need to look at our pipeline, which is going to orchestrate the build and the deploy processes, which is code pipeline. Code pipeline is also a fully managed service. And if you have used other pipeline services like Spinnaker or Argo CD or something like that, code pipeline is very similar to that too. And it allows us to orchestrate that entire process. And the best part of code pipeline is like it uses some sort of like webhooks similar to how GitHub webhooks work. So the moment you commit your code, it picks up the change, it builds, tests, and deploys the code as well. And this is the process that we will see later in the demo. So going a little bit deeper into code pipeline, we have the source first. Let's say GitHub or Bitbucket or even our own AWS code repo, which I will look at in a little bit. So you go from source to the deployment. And in between, we have the build process. This entire thing is the pipeline. So let's look at this in a little bit more detail. We start with that pipeline. We have our individual stages, source stage, build stage, and deploy stage. And within each stage, we've got an action. So within that build stage, we can have even multiple actions as well. Or within that deploy stage, we can actually deploy to different targets as well. The process that happens when one stage goes to the next stage is a transition, and the reason why we actually talk about the transition here is with code pipeline, you can actually stop the transition. So you can for example, you can do a build once you commit your code to a repo, but let's say you don't want to deploy, you can actually stop the transition in between the build and the deploy process. Then the next service I want to talk about is Code Commit, which is our managed Git repository. Very similar to GitHub, but it's private and internal repositories. You can use your standard Git process with this. It's backed by S3. And because it's backed by S3, you can also encrypt with your own encryption keys. There are no size limits. And because it's an AWS service, it's also got hooks into our notification service or even Lambda as well. So for example, once you commit something to your repo, you can trigger a Lambda function to fire. Why do we need source control in the cloud? Firstly, it's fully managed. You've also got GitHub Enterprise, but if you want to store everything or use everything AWS, we've got something for you, which is essentially what code commit is. Because it's all Git based, you can still use either SSH or HTTPS to either pull, clone, or push the code. And the index is in DynamoDB. Again, this is not really something that you will use on a day-to-day basis, but it's sort of like useful for you to know. CodeStar is that entire platform that covers all of these things. So if you want to develop and manage your entire software development and deployment process, you use CodeStar as your tool of choice. I understand that there's a lot of stuff here, and I'm also kind of rushing through all of the slides as well. So if you have any questions, please do feel free to put them in the chat. I can cover them a little bit later. Traditionally, the developer used to do all the debugging by themselves. I'm not a particularly great developer, so the way I do debugging is I always do an output of that particular variable to see what that variable holds at different stages of the development process. Obviously, that's a really crap way of doing it. There are a lot more efficient ways of doing this, but what I'm trying to say is it's always been with the developer first. Then once you compile the code or build the code, you test it, and then you look at the logs. From the logs, it goes back to the developer and the cycle starts again. Adding breakpoints is yet another process. Like I said earlier, not such a great developer, so I don't actually use breakpoints. I just make it really crude. But then again, I don't need to develop for a day job, so I think it's okay. Fuzz might disagree, but yeah, hey, we'll see how it goes. Okay, so looking at logs from the developer, testing, and logging. So how does X-ray help? X-ray is a little bit more detailed into that logging process. So it's not just breakpoints, it's not just variables. It's actually going deeper into the code and identifying specific issues like specific performance bottlenecks and how those bottlenecks impact users, identification of errors, and so on. Additional use cases for X-ray, we can even use it beyond the cloud. We can write custom payloads to test for specific scenarios. We can do deep linking with the exact variables and how those variables behave, how those functions behave. So in the console, you can actually see the exact output of those functions, even in a fully built and container in production. The output you can filter, so that's also an advantage. So you can filter with specific functions, you can filter with specific variables, and so on. And because again it's API driven, we can write custom code to pull that data out of X-ray and present it in a web page or some sort of portal or something like that. So how does X-ray actually work? So it traces requests made within that application, records traces, and then uses a sort of service map to see how those functions talk to each other. For example, if you have only web-based services, you can look at the HTTP status code for each of those services, and we can also use X-ray to track over a period of time what that application has been doing. How do we use X-ray? We have the agent within an EC2 instance or within even a container. That agent pushes data into the API, and you can do this either within AWS or even on your on-premises servers. All of that goes to the API, and then finally you can see see what's happening in the console. I did not actually talk about this earlier, but I just wanted to add it in. Some of you might be familiar with Cloud9 already. What Cloud9 is, it's a fully cloud-based IDE. So it gives you an entire IDE right within your browser. And because it's sitting on AWS, it's actually an EC2 instance. So you can even SSH to the EC2 instance. You can modify binaries within the EC2 instance, and you can run your code directly from Cloud9 and make it behave as though you were running it in production because it's already on AWS. It's pretty cool. This is how it looks like. I will actually show this to you during the demo. And finally, I wanted to talk to you about how continuous delivery for containers actually work. So you go from source to build to deploy, but how does that work in a container perspective? So you use code commit or GitHub to write your code. You orchestrate the entire thing with code pipeline and use code build to build it. Once you finish the build process, you can push the code to our container registry, which is ECR. You can either deploy it to ECS. ECS is our managed Docker service, or you can also deploy it to EKS as well, which is AWS's managed Kubernetes service, which I have not shown yet. Finally, I want to talk to you about the demo, but are there any questions? No? Okay. Right. So, Faz, are you still there?
Yeah, I'm here. We'll take the questions at the end. There's a question here, but we'll take it
Okay.
at the end. Yeah.
Okay, cool. So now I want to show you the demo. So this is how Cloud9 actually looks like. And what I'm going to do in this demo is I'm going to make a change to my code. And once I make that change to my code, what happens is code pipeline will pick up that change and then deploy this code into an Elastic Beanstalk application. So this, let me just go through what I'm doing here. So this is Cloud9, the IDE. I've opened up a HTML file here. I'm going to make some changes to the HTML file in a bit. Once I make those changes, I will commit them to my code repo, which is this. It's actually just a sample pipeline. So once I commit the code, what happens is code pipeline picks that up and pushes it. So let me just show you how this pipeline looks like. So it's a very simple pipeline. It's just going from source into Beanstalk. There is no build process here because code commit has a direct integration with Elastic Beanstalk. So what happens is code commit just takes the code and just pushes it directly into Elastic Beanstalk without having to build a container. And the reason is Elastic Beanstalk accepts zip files as a package, as a deployment package. So there is no build process in that sense. That's not entirely true. There is a build process, but Elastic Beanstalk takes care of that build process because it's a fully managed platform as a service offering. So we don't do that build process in this pipeline. So let me just make that change here. So what I will do is something like that, and before that, I want to show you how the page actually looks like. Sorry, that's not the right thing. This is what happens when the demo gods don't actually help you out. So this is the initial page. The reason why you saw a green page earlier is because that is the original deployment. And because of my browser, for some reason, it doesn't want to update it. So I have to open it in an incognito window. So as you can see, the code here, it says, for next steps, read the AWS code pipeline documentation and don't tell me about it. So what I'm going to do is I'm going to close this. I'm going to make a change that for next steps, read the AWS code pipeline documentation and tell me all about it. Okay, so I save it. Now, I mentioned that Beanstalk only accepts zip files for the application package. So what I will do is I will push that zip file. I'm sorry, I'll push the new HTML file inside that zip file. Okay, now I can when I do git push origin, once it pushes, you can actually see that my repo has gotten updated. My pipeline is now going to trigger. It says in progress because it just picked up that change. And I can actually see the commit message here as well to see what it's exactly doing. So this is my useless commit message, which code pipeline picked up. And it's now pushing that zip file into Elastic Beanstalk. So if I go into Elastic Beanstalk, I can actually see that it has just updated the environment, but it's not pushed the code just yet. We still do need to wait. Here it says successful, but let's see whether it is actually done here. Okay, don't know if it is completed. Yes, it is actually completed because it says new application version was deployed to running EC2 instances. So let's see if it actually has deployed it. Right, there we go. It has actually deployed the latest version. So now this is the code change that I did a little while ago. So that's it. That's the end of my demo. And that's all from me. So thank you very much for being so patient and paying attention, even though I sped through it like a bullet train. So thanks.
Cool. Thanks, Thiru. Just to add on to one bit of the whole introduction to DevOps, just for the crowd over here, right? Because we have a mix of an audience. Usually, the university students and people who are just joining the workforce or just been there for like a year or two. Where do you think they should start with on DevOps? Is it something they should be worried about in the first place? Because if you take any uni students projects like the final year project, the FYP, I mean, deployment is either on a local host or maybe on a virtual server somewhere. So where do you see DevOps fitting in that whole cycle of how they do things versus how it is currently being done in companies? You're muted. Yeah.
Yeah, I muted it. Sorry. Obviously, having a knowledge of DevOps is really important because this is how things are done in the real world. Coming out of college and university, you don't really get taught what DevOps is, or maybe you do, but you don't get an exposure to the tools. So having an understanding of the tools and the process is really important for you to start your career as a developer or a systems admin or an engineer or something like that. But for an FYP, having that CI/CD or that DevOps pipeline or whatever in place is more from a learning perspective rather than anything else. So I would say use it for learning, but not necessarily something that you need to focus on, or at least that's just my thoughts. How about you? What do you think, Faz?
Mm. It's a good question because here's the thing, right? The thought is for students and for people who are just joining in, they just want to make sure they can get the work done,
Hmm.
and they're just trying to understand. Already, the whole system is becoming more complex. We have so many languages coming in. You're
Hmm.
having now even different architectures, monolith versus microservices. More decisions are being put upfront versus just getting into the code and starting the work. And now
Sure.
DevOps has just come across as another thing to add. But that being said, I would definitely suggest anyone to actually look at what DevOps is as a concept first, and try to at least use some of the tooling. Like a CI/CD server is very useful because if once you actually get into a job, what's going to happen is you'll actually notice you'll be having very frequent conversations where you've written certain code and it works on your machine, and then when you actually deploy it, it doesn't work on the production server.
Hmm.
And that's a conversation I've had like 15, 16 years ago. And Thiru, I'm sure you would have also seen something similar. And
Mhm.
uh, and anyone who's now going to join the workforce would see something same. So the idea is that having even something like a CI server, which is basically a build server, what Thiru showed is you have a separate machine that compiles the code, builds the code, and then does certain things on the code like unit testing or integration testing, which is one of the questions which I've been coming up to next. Having that server separately enables you to have a separate system that can handle this so that you can remove all the unknowns of trying to make or build the code on your machine, right? And your machine could be custom. Your environment could be custom built for some certain things. You may have updated the libraries, for example. If you're in the JavaScript ecosystem, Node.js, I mean, it's crazy, right? The libraries just keep changing almost every week, and you would
Every day.
update your libraries. Yeah, I mean, it's JavaScript fatigue, right? That's what it is. Yeah, here I am complaining about JavaScript. Yeah, but it's basically you want to make sure that the environment you are building your stuff in and even deploying to should be constant or uniform as much as possible, which is where a build server helps you. There are a lot of services available online. You could install stuff of your own. You could use something like Jenkins and other things, or AWS has code build, or you could also use other services like GitLab, or if you're using GitHub, then GitHub has GitHub CI. Different services available out there. I would say it's less of an excuse not to even know what it is and what you
Mm.
can do with it.
Mhm.
So definitely something to have a look at. So
Um,
yeah, that's yeah,
so yeah,
yeah.
yeah. Just to your point of having that external build server, right? I think it's also like a really good learning process if you adopt it from day one, because it prepares you for the real world in that sense. So even when you are working on your own code or even like a side project or anything like that, having an external CI server also gives you exposure to that entire process because, of course, as a student, it's all on your local machine. It's on your laptop. You build
Right.
it, you push it to localhost, and that's it. You present it, and you're done. But that's not how an actual career works.
Yeah. So you want to, as much as possible, code and deploy as real world scenarios are, right? In an actual
Yes,
job, in an actual production environment,
sure.
which kind of helps in this way. Yeah. So thanks for that. Here's the next one. So we have Ayman. I'm flashing down the screen. So we have Ayman who's asking about how to do unit testing exactly, and what the process is, right?
Right.
Yeah.
So, in true Amazon fashion, I will actually admit that I'm not a very good resource when it comes to testing. However, Fuzz definitely can put some
Uh,
skill sets.
yeah, yeah, I totally. So, thanks for putting me on the spot. Let me just think on this. Right. So, unit testing comes in there are different forms of testing that have come across. Now, if you, I'll go a bit back into history. With this case, 15, 16 years ago, the only way we could do testing was manual testing in the early days. And then someone came up with the idea that, hey, you know what, you can actually codify your test cases and then run it against the code which you're writing, which is where unit test cases started coming out. Now, there are different test cases when you would classify them. You have unit test cases, you have functional test cases, or integration test cases, and then other kind of things also. Unit test cases are usually what you would write to test against a function which you have built. So, for example, let's say if you're using any standard language that has OOPS, for example, so you would be writing a lot of modules, you would be writing a lot of functions internally. Let's say you're building a bank application, and then as part of the bank application, you have a model, which is a bank account, right? And as part of the bank account model, you're saying, okay, this bank account has certain functions that associate itself to be called as a bank account, which is that you can do credit, you can do debit on the account. Now, when you write that code, you want to test it. Now, the only way in the old days, traditionally, we would test all of this is that once we write the code, we would build everything together and then deploy it into some environment where you have a database and then test it. What unit tests allow you to do is that you can circumvent that whole process, and then just when you're compiling the code, as part of compilation or building the code, you can actually say, okay, I want to, you'll write another set of classes called test classes, depending on which framework you're using. If you're using Java, you would use JUnit. I don't remember the others, but yeah, I mean, you have a lot of them available out there. You would write a code like maybe you would test certain edge cases on a credit on a debit function, right? So, for example, when you're debiting money, you would want to check what the balance amount is in the end. So you would hard code certain values. You would say, okay, when you actually credit value, will it increase or will it decrease, right? And then whichever way is incorrect, then you would test for that and then say it's a failure, which means it's a success. So, for example, when you debit amount, you are actually going to be removing money. Am I right, or am I confusing both of them? I usually confuse credit and debit. That's why. Which one is which, Thiru?
Not entirely sure if like
Yeah, exactly. So fair enough. I mean, so yeah. So with credit, what happens is that you're actually adding amount. Debit, you're removing amount. And
sure.
When you actually put a function and you put a method, you want to make sure that the credit method is actually adding amount and not removing amount from your account, right? So you would test it with different values. You would also test, okay, if can I credit it with a negative amount, right? Or can I debit an account which is already at zero? So how would that work? If there's a threshold value for an account to be credited, can I test that? So you would test all of that within the code. So you would write different cases in the code itself, and then when you run the test cases along with the build process, for example, or when you're compiling it, it will run all that the different code, and then pump in the values, and then test that function, and then pump it out, and it'll give you a result saying, okay, for this case, which you are assuming, you are asserting. So you'll do an assert condition at the end saying whether this is the scenario you're supposed to get or not. And then it will decide whether it's a failure or a success. So you'll get a nice, pretty report. If you're using a command line, you'll get in the command line. A lot of them give you HTML reports also. And one of the things as part of the unit test is that you will also be writing code to spin up a certain environment or spin it down. Or you would mock certain things, because a unit test case is just for a function. So if that function is dependent on a third-party service, you would want to hard code what the third-party service gives. So that's basically called mocking. So it's a pretty wide topic. We could have a 1 hour just on unit testing itself. But I can understand why you asked unit testing, because in DevOps, what happens is when you actually build the whole CI/CD pipeline, you want to be adding automated tests throughout the pipeline, right? As part of the process. Unit testing comes early on. So as part of the CI server, when you're building the code, once the code is built, and maybe even before the final code artifact is built, you would want to test whether this code is passing the main test cases which I've written at a function level. And if it fails, then you'll stop the build and you say, oh, you know what, I'm not going to go ahead with the build because this the code which is written is incorrect from a rules perspective, or policy, or functional perspective. So that's how you would want to start. Yeah.
Sorry, no, I just wanted to add on. Testing is not just, just because your code compiled correctly does not mean that your code works.
Exactly. Yeah.
So just like what Faz said, you need to account for edge cases and corner cases and stuff like that. So because especially, for example, you do simple validation, right? When you accept values. So testing is basically taking those validation processes to the next level and actually imagining how that particular function of the service will work at scale, for example. Those also does constitute part of testing.
Yeah. So so that's how you could start with. And maybe what we could do is, since this question's come up, we can add this as a future topic on how to actually get testing. Although it has less to do with the cloud, but yeah, why not? So that's kind of like what we would do in that case. I don't see any other questions. Right now. So so with that, thanks Thiru. Appreciate your time today on a Friday evening. Thanks for sharing on DevOps, and we hope to see you soon next time. Yeah, thanks. I'll just remove it from the stream before I say bye to everyone. Bye.
Bye, guys.
Yeah. All right, cool. So with that, we have let me just bring back my main screen over here. So with today's session, we've started getting a bit more deeper into application development and DevOps and CI/CD. I hope you guys liked it. Here's the feedback form. Do please put in your feedback over here. We want to make this content much more oriented towards what you all are looking for. So do put in any details, look at different topics you're actually looking forward for, and then we'll add them onto our to our list, because we are seeing that there's more traction happening in right now among all of you, because we are getting a mix of crowd right now. So we may be actually spinning off newer topics sooner. Like app development is one thing, because we think it needs more time. So with that, thank you so much for joining us today on a Friday evening. And next week, we're going to be having another guest who's going to be talking on containers. So if you have been always interested in Docker and Kubernetes, and you've heard all of these terms being thrown around about containers, how is it different from Tupperware and all these other things, do join us next week. And our guest is actually going to show you how you could build a simple container of your own and deploy applications. So with that, thank you so much. Have a safe weekend, and see you next Friday.